Okay, here we are on Unit 2B, Big Ideas, and for this video we're dealing with similarity. So similarity, as a reminder, you have the same shape, but your size has probably changed. And so the triangle similarity postulate that goes with similarity is, there's only one, and it is angle, angle, or at least that's the one that we focused on, angle, angle. So if you have two angles that are the same in a triangle, then they are similar. When we're dealing with similarity, we do have to be aware of this idea of scale factor, because with similar figures, usually a dilation has occurred with that figure. So we need to know that to get the scale factor, we need to do the image over the pre-image. So like the length of one side of the image divided by the length of one side of the pre-image will give you your scale factor, like how much did it get bigger or how much did it get smaller by that scale. So let's look at these following examples. We have, are the following triangles similar? So for this first one, and remember the thing that we need is angle-angle similarity, or that all of the sides are proportional. So for this first one, I'm not seeing anything to do with sides, but I am seeing angles. I've got two curves right here, three curves right here, one curve right there, and I do see a vertical angle, so I'm gonna mark that as well. 1, 2, 3, 4. 1, 2, 3, 4. So these are the same. However, do I have, let's refocus, do I have two angles that are the same for both triangles? No, I don't. This one's 4, this one's 1, this one's 4, but there isn't one that's just one curve. So no. Looking at the second one, we don't have any angles that are given for these triangles, but we do have sides. So we can use scale factor to understand if they are proportional, if the sides are proportional. And I'm going to say, like, this is our first triangle and this is our second triangle. So this is our pre-image and this is our image. So I'm going to do image over pre-image for all of my sides. So 12 goes with 72, so 12 over 72. I've already calculated these. Remember that you can use the Desmos online calculator, or you can even like type in fractions into your Google search bar, and you can use that as a calculator as well. So there are some online options. 12 over 72 is 0.167. So that's these two sides. Let's do the hypotenuse of these triangles. Image over pre-image, 14 over 84. 14 over 84 equals also 0.167. But I can't just stop here. I need all three sides to be proportional. So let's do the last side, and that would be 8 over 48, image over pre-image, and it is also 1.67. So all of these proportions are the same, therefore, yes, similar. So you're either showing that all of your sides are proportional or that you have angle-angle similarity. For these next couple of problems, it says the polygons in each pair are similar. So we already know they're similar. Find the missing side length. So since we already know they're similar, we know that they're proportional. The sides are proportional. So we can set up our proportions. 10 over 15. So that one over that one, those are corresponding, is equal to, I'm going to label this x. We don't know what it is, but we want to find it. X over 24. So, x over 24. Your next step to find x is to cross multiply, and to solve for x. So 10 times 24, 240. So this is cross multiplying. And then x times 15 is 15x. Divide on both sides. Then you, of course, would be doing this in your calculator. And then you get x equals 240 divided by 15. And that equals 16. So x equals 16. And we did that by setting up our proportions, cross multiplying, and solving for x. Number 2, I'll let you pause the video and try and solve this one yourself, and we'll come back. Okay, so here I see that 12 goes with 15. Those are corresponding. And so 12 over 15 equals, this is what we're trying to find, label it x. 12 over 15 equals x over 25. Those are corresponding, x over 25. Cross multiply, 12 times 25 is 300. 15 times x, 15x. Divide by 15 on both sides, and you get x equals 20. So that missing side equals 20. Okay, and then we also have, with similar triangles, this thing called the triangle proportionality theorem, the side splitter theorem. You might also see it written like that, which states if a line is parallel to the base of the triangle, it splits the remaining sides proportionally. Okay, so we can use that. We can use this idea of proportionality to solve for a missing side. I see for number 1, there's a question mark, so I'm going to label that as an x. So that's what we're trying to find. This got cut off. It's supposed to be 14 right there at the bottom. And to set up the proportion, I'm going to need to know what this length is. Well, the whole length is 14, and this length from here to here is 4. So therefore, to find this missing length, you would do 14 minus 4. 14 minus 4 is 10. So from here to here, the length is 10. And now I can set up my proportion. So we can do that. We can do 10 divided by 4. 10 over 4 equals 15 over x. 15 over x. Oh, okay. And so we cross multiply. 15 times 4 is 60. And then 10 times x. Divide by 10 on both sides, and you get x equals 6. This missing side from here to here is what keeps going in and out. This side here to here is 6. Okay, and then number 2, I'll let you pause and you try to solve this one by yourself, and then we'll go over it. Okay, so we're looking for the entire length now, but to get the entire length, you're going to need the parts. So from here to here is 25. From here to here, I have no idea. So I'm going to label it x. I do not know what it is. Here to here, the entire length is 24. Here to here is 15. So I can do 24 minus 15 and get, oh gosh, it's 9. Yeah. Yeah. So 9. And now we can set up our proportion. So we can do 9 over 15. 9 over 15 equals x over 25. X over 25. So I'm doing like top divided by bottom, top divided by bottom. Cross multiply. 9 times 25 is 225. X times 15 is 15x. divide by 15 on both sides, and you get x equals 15. Is that my final answer? No, it's not. So I just solved for that x, which is 15, and this is 25, but I'm looking for the entire length, this question mark. This question mark length would therefore be 15 plus 25, so that would be 40. The question mark length equals 40. Okay, so I'm going to flip the page and we'll get started on our practice EOC problems. So this first question says, look at the triangle. Which triangle is similar to the given triangle? So I see that I have two angles already given, and then the answer choices are triangles with other angles. Remember, to prove similarity, or seeing if it's similar, you need at least two angles that are the same for the triangles. Well, I see like this 77 and 52. I do not see that in my answer choices, both a 77 and a 52. So pause the video and think about, is there any other way that we could have two angles that are the same? Okay, so in thinking about this, we also need to see, well, what's this angle right here? Like this angle might show up in one of our answer choices. So by the triangle sum theorem, the sum of the angles, the interior angles, sum to 180. So you can do 180 minus these two added together, 77 plus 52, to get this missing angle. This missing angle is 57. Or wait, sorry, not 57, 51. 51. So this missing angle is 51. Does 51 show up in one of our answer choices? Yeah, it does right there, 51. And then there's the 77. So do we have two angles? Yes, we do. We have two angles for both of these triangles that are the same. Therefore, these two triangles are similar. And then you see that the others just don't work out. Then D didn't even give us any angles, so that was obviously not correct. Moving down, it's asking us to prove the diagram shows right triangle ABC, ABC with altitude BD. Prove that triangle ABC is similar to triangle BDC. Write your answer in the space provided. I'm actually going to pause the video right here and we'll come back for part 2 to finish this proof.